Lesson 6 talks about the slope of a fitted line. We're going to be looking at how changing one variable changes another. The success criteria is to use the slope of a line fit to data in a scatter plot to say how the variables are connected in terms of real-world situations. We're going to start by revisiting slope from previous units. And we're just going to look at estimating the slope of a line. So on 6.1, as that left side is loading, go ahead and take a moment and think about what the slope of that line is. Now that you've had some time to think, you might have used some of the given points to help you estimate it. So let's think about maybe using the points 5, 2 and -4, -6. Now, if you recall slope triangles from way back in the earlier units, we look at finding slope as the change in the y values over the change in the x values. So if we look at that change between our y values here, I see that that's 2 minus a -6. And then the change between these values here, I would see is a 5 and a -4. Or if you have them reversed, that is just as valid. But that would give me a slope of 8/9. But those points are not exactly on the line. So I would say the slope is a little more than 8/9. Now, maybe you didn't use those points. Maybe instead you used the point 8,3 and for -4, -6. And if we looked at a slope triangle like that, maybe you estimated this to be more like 9/12, which is equal to 3/4. And if you use those points, we would say the slope is a little more than the 9/12 if you're using those points. So that just kind of brings you back. But let's think about, now if you look on the left side of the screen, would it be better to use points that are close together or further apart? So let's think about if you're looking at all these different lines that we have here. You see the red line represents the 5, 2 and the 8, 3. Excuse me. The yellow line represents the 8, 3 and the -4, 6, and the blue line represents the 5, 2 and the -4, 6. Which of those lines do you think looks closest to the black line, which was the given line? And it almost looks to be like that blue line is closest to it. Some might argue it's the yellow. But just remember, keep those slope triangles in mind. And when you're drawing a slope triangle, it's telling us that. Sorry, I'm reading something and just trying to analyze what I'm reading. Never mind. So it's telling us that we're looking at that change in y over change in x as we move forward. Sorry, I brain farted for a second. If you're not my students, I also am sorry. Okay, this is my 6th video in a row, so I'm getting a little delusional. Okay, let's move on. 6.2. So we're going to be describing linear associations. So recall our investigation between car weights and fuel efficiencies from a previous lesson. We looked at positive and negative associations between two variables. Think about how you might describe the relationship between the weight and the fuel efficiency. So we might say that the scatter plot shows that for these cars, as the weight of a car is increasing, the fuel efficiency is actually decreasing. So we're going to make some connections in this activity as far as using that language as you know, what is happening to our horizontal axis versus what is happening to our vertical axis. So for each of the scatter plots, we're going to decide if there's an association between the two variables and describe the situation using one of these statements. Take a moment to go through those statements. So you're going to have to flip your page. My page looks different than yours, but you'll flip your page and you'll see those 3 different scatter plots, and then you'll flip back and you'll fill in the blanks. Okay, now that you've done that, let's go through them. So our first one, which was the price and the mileage, we would say for these data, as car mileage increases, the price tends to also increase. So in just thinking about that, I'm not going to fill that in because that is on the left side of the screen, but is it surprising that the price decreases as the mileage increases? That's just something for you to think about. Why doesn't the mileage predict the price perfectly? So again, just kind of reflect on those questions. The next one, we would say that for these data, as diamond weight increases, price tends to increase. So again, reflect on, is it surprising that heavier diamonds cost more? Why doesn't the weight predict the price perfectly? And if you recall from our last lesson, I forget which lesson it was, there are other factors like the cut of the diamond, the clarity of the diamond, things like that. The next one we would say for these data is, now your book might have a typo in that 3rd bullet point, but we would say that for these data, as daily high temperature increases, the energy consumed tends to increase here. So if that confused you, go ahead and fix that in your book. Do we think that this is surprising that energy consumption goes up as the temperature increases? I'm going to say no because of things like air conditioning. What might cause more energy consumption on a cool day? Well, people might be doing laundry. Maybe they're using power tools, things like that. What might cause less energy consumption on a hot day? Maybe being gone from home. Okay, so now that we've looked at those comparisons, we're going to move into actually interpreting some slopes, which you are going to find on page 43. Earlier, we looked at the price and mileage of some used cars. We saw that for these used cars, the price tends to decrease as the mileage increases. So here we have an example of an equation for the line, which is y equals negative 0.073x plus 17,404.485. From the equation, we can identify the slope of the line to be the negative 0.073. So think about, what does the slope of the line tell us? Well, if you're looking at that scatter plot, it means that for every increase in 1 mile, the model predicts that the price of the car will decrease by 0.073 thousandths, so 73 thousandths of a dollar. So keep that in mind because that's what's going to be related to our work that we're about to do. So in this activity, you're going to determine what the slope of the model means for 3 different sets of data. You're going to first identify what the slope of the line in the scatter plot is for each of the situations, and then you're going to say what it means. So just like we did on that last slide and saying that, it means for every increase in 1 mile, the model predicts that the price is going to decrease by that given dollar amount. You want to write a written sentence to represent what does your slope actually mean. Pause the video, take a moment, and then you're going to do those and we'll come back together. Okay, so for this first one, we're going to say that the slope is approximately 5,521. And then a good written statement would say that if the weight of the diamond increases by 1 carat, the model predicts that its price increases by $5,521. Going into the next one, we would say our slope is negative 0.011. And in this situation, if the weight of a car increases by 1 kilogram, the model predicts that its fuel efficiency decreases by 0.011 miles per gallon. In that next one, which is our last one, we would say the slope of the line is 0.59. If the daily high temperature increases by 1 degree Fahrenheit, the model predicts that the energy consumed increases by 0.59 kilowatt hour. So now in thinking about all of that, what was the easiest way to find the slope for each situation? And since you're given that equation, if you look at the coefficient of the x-coordinate in the equation, that is your slope. We all remember seeing way back on early in the year, y equals mx plus b, so that m value, which is the coefficient of the x-coordinate in the equation, is going to identify the slope for you. Do the answers for the meaning of the slopes make sense in the context of the problem? Because talking about the slope in context is part of our criteria. So we would say yes, the diamonds are usually expensive, so 1 carat increase is likely to cost a lot more. If we're talking about a 1 kilogram difference in the weight of a car, it's not very much, so it may lower the gas mileage, but not by much. And then a 1 degree temperature increase is not really significant, so it should not need a lot more energy to cool off a building, but some would be needed. So in terms of those 3 different situations. What is the difference between a positive slope and a negative slope in your interpretation? Well, positive slope means both variables increase together, but a negative slope means that when one variable is increasing, the other is decreasing, which is what was shown in the last one. So as the weight in kilograms increases, the fuel efficiency is actually, ooh, that's an awful arrow. The fuel efficiency I just sounded like Shakira, by the way, if you guys know what I'm talking about. The fuel efficiency is decreasing. Okay, let me keep it moving. The last question I have here is the model for energy consumption and temperature predicted a 0.59 kilowatt hour increase in energy consumption for every 1 degree increase in temperature. Estimate how much the temperature would need to increase to raise energy consumption by 6 kilowatts. And it would need to increase a little bit more than 10 degrees. Okay, moving on. This last piece, is it positive or negative? But we're going to be a little bit more specific than that. So while some data sets have a linear association, which we've talked about, others do not. A linear association is present when the points in a scatter plot suggest that a linear model fit the data well. Some data sets have nonlinear association when the scatter plot suggests that a nonlinear curve would fit the data better. Still, other data sets have no association when the data appears random and no curve would represent the data well. For each of the scatter plots, decide whether it makes sense to fit a linear model to the data. If it does, would the graph of the model have a positive slope, a negative slope, or a slope of 0? So at this point, you're going to want to pause the video and go ahead and give this a try on your own. I'm going to make this a little bit bigger because I'm going to be really just focused on this left side of the screen right now. Okay, let's go through the work together. You should have done it on your own and paused or something. So all of them are going to be linear models except for D. D, you would not really be able to tell if there is a positive or a negative association, which is going to be the next piece, but you would not be able to represent it with a linear model. A and C, we would say are negative, and then B and E, we would say are positive. Which of these scatter plots show evidence of a positive association between variables, and then of a negative association, and which do not appear to show an association? So we've already said B and E have the positive, A and C have the negative, and then D has no apparent association is what we would say. Would you be able to notice a linear association from the data in a table? It might be possible by finding the slope between each pair of points and then seeing if they are close, but it would be very difficult, so using a scatter plot is much easier. So what does it mean to have a positive association? Well, when the points generally go from the bottom left to the top right, there should be a positive association. If you take a look on page 46, which is in your lesson summary, how would you describe the trend in this scatter plot? What we would really say is the height of the dog increases, its weight tends to increase. So that's in terms of its description, we're using the quantities, right, to describe what's happening. As the height of the dog increases, the weight tends to also increase. When there is an association between two variables, how can we tell if it is a positive or a negative association? As the height of a dog increases, oh, that was the last slide. Oh, I never changed the words there. I'm so silly. Okay. Why can't it click? There we go. If the dependent variable tends to increase as the independent variable increases, it is a positive association. And if the dependent variable tends to decrease, then it's a negative association. Also, a line that fits the data well will have a positive slope. The slope of a fitted line is 4.27. What does that tell us about the dogs? It tells us that for every 1 inch increase in dog height, the dog's weight increases by the 4.25 pounds, which I think there's a typo there because those slopes don't match. So 4.27 or 4.25, whichever one it's supposed to be, 27. That's a typo. So all in all, you should be successful after this if you can use the slope of a line fit to data in a scatter plot to say how the variables are connected in a real world situation. That heavily relates back to, where is it? I passed it. It heavily relates back to the fill in the blank, wherever that was. I never filled it in. Here. This heavily relates back to there, describing the connection between them in written words. And then also being able to say that association, which was what you did in that last activity, saying if it can use a linear model or not. Awesome, awesome, awesome. Sorry I was a little delusional in that one. You will then do, for my students, 1 to 4 for the practice problems there. If you're not my student, sorry, whatever your teacher tells you is what you got to do. All right, I'm out.